This is an HLF 200 cable, and we'll see how we can measure the length of the cable using NanoVNA. Then you might ask, why should you use a NanoVNA to measure the length of the cable? You might as well do simply using a tape. That's right. But the reason is that the NanoVNA is measuring the length up to the first fault. So that if there is a break in the cable, it will measure the length up to the first fault. Suppose there is a fault in the cable at 5 meters, say. Then NanoVNA will tell you there is a fault at 5 meters. The cable may be 20 meters long. That is the reason why we want to use NanoVNA to measure. Not that this cable is much easier to measure with a simple tape. And moreover, when I bought this cable, I know the length which I bought also. For measuring the length of the cable or the distance to the first fault, we use this S11 port. It's also sometimes called S11, the first port, which is for the reflection. We should also have an idea of the approximate expected length. Then only we can set the settings in NanoVNA accordingly. But if you do not know the approximate length, then you have to use trial and error methods. That is signal transmission to the first fault or the end. That is what we are going to measure. So you should have some idea. For that you set the frequencies in such a way that a good resolution is obtained for that range of length. Another thing which we need to know before measuring is the velocity factor of the cable. HLF 200 has a velocity factor of around 83%. That means signal will travel through the cable at 83% of the speed of light. That's what is meant by 83% velocity factor. There are several tracings in this NanoVNA. We don't need all of them for the measurement of the length of the cable. We need only the first tracing. We select the menu, and from the menu get the display. Once the display is obtained, go to trace. So many traces are displayed. We only want trace 0. So touch all the others and remove it. So all the other tracings have been removed. Only trace 0 is remaining. Now go to channel and make sure that the S11 is set at reflection, REFL, reflection. Next we want to format the reflection. That is S11. And from the S11 you go for more. And in the more you select linear. Go to transform and then choose low pass impulse. Then transform should be switched on. Now it is off. It has been switched on. And here you have to set the velocity factor. Default scene here is 70. Velocity factor is set like this, 83, then percentage. So it will be set. Now we'll set the frequency limit. Start will be set at 50 kilohertz. And stop will be set at 200 megahertz. With 200 megahertz set as upper limit, you can measure up to 24.31 meter length of coax. Now I have connected the coax. I could move this jog wheel and bring it to the peak. See, the measurement is seen now. Alternate method is to search you take the marker and search maximum. So it has shown the maximum there. Practically same, 10.94 meters. That is what is shown here, the length of the coax. This is actually a 10-meter length which I have bought, but there is some extra length here. You can see that connector is here, and there is a jumper wire also here. The coax has not been connected directly, so that will account for the 10.94 measurement. I have added one more similar piece using a barrel connector. You can see that the curve has shifted and there's a different maximum. Now the peak has been found 21.63 meters. When two cables have been connected, it is 21.63 meters. Of course, there is some margin of error. The actual length which I bought was 20 meters, 10 plus 10.